Economics Tutoring Center at ASU, and today we're going to do a video on confidence interval proportions. So in the past we have done a video on confidence intervals, but in this case we're going to deal with proportions, and the only difference is when you're calculating standard error, there's a different equation. So we're just going to go through a quick example and try it out with this equation. And so let's say you have, we'll solve it for the 95% confidence interval. So let's say you have 100 people, so that would be your sample size. So 100 people are using this app, right? And so if you have a percentage, that's what the proportion is. So let's say you do a survey and you find out that 36% of the people are using your app. So what you do is you take this percentage. Sometimes you'll see it in problems where it's a percentage, and sometimes they'll give it to you as a decimal. And in this case, for this type of equation, we'll want it as a decimal. So that would be P, because that's your proportion, because it'd be out of 100, and it's 0.36. So this is what we're going to use now when we solve for the new standard error to find the upper confidence level and the lower confidence level. So now all you're going to do is we're going to plug in these values to figure out the rest of this equation. So first we can solve for standard error, because you'll need that for both of these equations. So what we do is we come back to the problem and we realize that the proportion is 0.36. So we plug that in for this p-value in both of these scenarios. So it's 0.36, or square root of 0.36, and then 1 minus this value, which again is 0.36, and then you put it all over your population. And in this case, we said we sampled 100 people to get our proportion, so it's all over 100. So then we're going to solve this out, and you do 0.36, and then 1 minus 0.36, 0.048. So now that we've solved for the standard error proportion, we're going to go back and solve for the rest of these variables. So far we already have P, because that's our proportion. We have standard error, so all we need now is this Z value. So one way to find the Z value is we have to first look at our alpha, right? So we're going to take 1 minus 0.95, which is our confidence interval, and that's going to give us 0.05. But if we look back in this equation, you have to find the Z for alpha divided by 2. So this is alpha. So now that we've solved for alpha, now we're going to find the Z. So if you look at the Z, it says it's alpha divided by 2. So what we're going to do is we're going to take this alpha, 0.05, we're going to divide it by 2. And in this case, we get 0.025. Take out your Z table and you pull up 0.025. So we solve for alpha over 2 to get 0.025. And so what we're going to do now to use the Z table, we're going to subtract this from 1 again. We're going to get 0.025. So 1 minus 0.025, 975. So now we found the value of 0.975, so we're going to go onto the Z table, which I have pulled up here, and we're going to locate the Z value using the top and most left column to figure out our Z value. So if you recall, we found the value to be 0.975, so we're going to look through all of these values to find that value. So we're going to scroll down, and if you see right here, it says 0.975. So how you determine the Z value from this is you then go over to this left side, and it's 1.9. So that would be the beginning of your number. Then you go up to the column that it lies in, and you get this 0.06. So the Z value would be 1.96, because you just add this decimal onto the end of it. So this is the value that we're going to use for both of these formulas. So now we're going to just solve for each of these, since now we have the Z value and the standard error. So the z-value and standard error, and then we already know our proportion from the problem that was given to us. So now all we're going to do is plug these in and solve out for the upper confidence level and the lower confidence level of a proportion. So we're going to start with this one, and it's going to be UCL proportion, and then we'll just plug it in. So in this case, the proportion is 0.36, so we're going to get 0.36. And then for the upper confidence interval, you add what you solved, and for the lower confidence interval, you subtract. So since this is the upper confidence interval, we're going to add these values. Then you're going to plug in the z, 1.96. Then you're going to plug in the standard error, which is what we solved for, so it'd be 0.048. So what you do is you solve this out and make sure you watch the order of operations on this one. So make sure you multiply these and then add it to this number. So once you do this, you get 0.4841. So in this case, this would be the upper confidence interval. To solve for the lower one, you plug in the same numbers, but instead you'll subtract. But in this case, for clarity, I'll write it all out again. So the lower confidence level, you get 0.36, and in this case, again, minus, because you're trying to find the upper bound and the lower bound of an interval. So you subtract it, and you get 1.96, which is the z we solved for, and then you multiply that again by the standard error we solved for. So 0.048. So when you solve this out, again, watching the order of operations, you get 0.2659. So what we've solved for now is the upper confidence interval and the lower confidence interval, and sometimes a notation that your teacher might have as like one of the answers or what they want you to write it in is in a set. So what you would do is you take the lower confidence level and you put that first. So in this case we solve for 0.2659, 659, and then you put a comma, and then you do the upper one. So in this case, it's 0.4841. So now we're done, and we've solved for the lower confidence level and the upper confidence level. Well, we can say that we're confident that our proportion will fall between these two numbers to a 95% confidence. So we're accepting a 5% error that it won't fall between these. So to summarize what we solved for, we looked back at the problem, and we realized that we had and in this problem we had 100 people who were surveyed if they used an app. So what we're doing is we then took this sample and we solved for the range of the sample proportions to estimate what the population proportion would fall between. But we only estimated it to 95% confidence, which means we're 95% confident that the actual population proportion would fall somewhere between 0.2659 and 0.4841. What we found is we were estimating the whole world's usage potentially, like the whole population's usage off of a small sample. So what we determined is that from this sample, ideally, the whole world population would be using this app between 26 to 48%, and with 95% confidence. Well, I hope this helped, and if you have any more questions, feel free to go to the Econ Tutoring Center or check out our other videos like the Z-Score one for extra pointers of how to do things.